Thank you. All right, so you may have seen this thing hiding in the foyer, and you might have heard something about a raffle ticket. So this is the 3D printer that I'm familiar with hacking. If you haven't got your ticket yet, first of all, you can get one after this. Secondly, we've decided that if any LCA delegates over the next month want to buy one of these things, we will donate 10% to cystic fibrosis. Okay? So it's something we make locally. We're big on local stuff. I mean, it's part of the open source concept, enabling people to do things locally. User maintainable. We do not agree with no user serviceable parts inside stickers at all. It's open all the way. It's open hardware, GPL v3. And we believe in people being able to upgrade it and hack it. So I spend a lot of time in the workshop hacking things. So that's what I do. And that's what my mum thinks I do. And this is what my wife thinks I do. And this is what the press thinks I do. But anyway, so 3D printers traditionally have been used, and oh yes, we've got to be able to print drugs and gems as well, according to Maurice Williamson MP. So 3D printers have been used to make bits to hack things. I mean, this is from Project RE, which upcycles various bits and pieces using 3D printed components into allegedly useful objects. Of course, some of the things that people come up with are not always very useful. An MG carrot, for example. So, well, let's talk about hacking the printers themselves. So, they were a hack from day one, of course. This is the one I built from Meccano to prove the concept that we could actually make a 3D printer that worked, just sitting there on the desk in an ordinary room. Couldn't find an ordinary room, used my workshop. And this was also known as Vic's Mechanical Glue Gun Destroyer. I think we got through 3 glue guns anyway. This was totally mechanical, and this was done in sort of pre-Arduino days. So, the mechanical hack at the time was the easiest one. But things have moved on. It's open source. It spreads around the world. It spreads into far corners of the world. Here we have in Togo some guys who take our e-waste and they hack this e-waste together to build 3D printers, which, of course, once you've built one 3D printer, you can make a whole load more of 3D printers with it, and so they can start propagating this technology across rather impoverished countries. And it's not just Togo, it's anywhere where there is a limitation on people getting hold of hardware. So, Palestine, Cuba, places like that. And it gives them a sort of local ability to scale up and fix things, which is really kind of cool. That's what we want to encourage. A little bit further along, close towards the Cape, we have Hans Fuchs, who, apologies if I pronounced that wrong, who's built this wonderful printer. And he's actually used a screw-driven feed to push plastic granules into the hot bit, rather than the plastic filament that you can see being pushed into those ones over there. It's not as accurate. You can't back it up, for example, to stop it dribbling and things. But it lays down a lot of plastic. It lays it down fairly quickly in really big, cheap, fast layers. And he has printed a lawnmower. It's a good one. Now, he actually printed it quite fast, so he's moving at 700 millimeters a minute. Typically, we move at 200 or 300 with that sort of scale thing. He's using a 2 millimeter layer height as opposed to about 0.2 millimeters with those. 3 millimeter diameter nozzle as opposed to about 0.35. And he can print this lawnmower in 9 hours, which is a pretty impressive time. So, moving towards the other end of the scale, we have another open source project, the Little RP, which uses a resin printer. So those are the ones that use some form of bright light source to polymerize a commercially made resin. And these are probably famous for being of higher resolution than the squirting little snail trails of plastic affairs. So 0.05 millimeter layer heights coming out of this thing, and it's done using one of those DLP projection or projectors, like we have a couple of up there, shining into this resin to photoset it. Can't quite make microelectronics yet, but I'll show you what 0.05 millimeters actually means. There's a match head. Closest one to the match head is 0.5 millimeters, furthest one away 0.1 millimeters. The layers being produced by the Little RP are half that thickness. So we're starting to get down to some really handy resolutions, and you know, with a little bit more work on the substrate, maybe somebody will be able to make some decent electronics one day. I hope. So, speaking of conductive stuff, yes, they can do metal. This is a wonderful hack. Now, there's a configuration called a delta bot, where you basically have 3 arms coming down to the print head, all right? And you can see the 3 arms there. They are pointing up instead of normally pointing down and having the print head hanging around under it. And so his print head, as it were, is, for those of you who haven't recognized one of them, a MIG welder, right? Which is a welder that's so simple a monkey can use it, basically. You pull the trigger and wire comes down, it fuses, so you can use it pretty much like a print head, though getting the actual printed object off the base plate is a little more fraught than just chiseling it off with a palette knife. It's not the sort of thing you're going to want to use in the living room. And for bonus points, you design it so that it doesn't drop sparks down into the electronics below. So, you know, there's a lot of hacking of 3D printers, printer designs themselves going on. But while people have been using 3D printers to make parts to support you know, their local requirements, their local artisans, hobbyists. We've got there the nice hot stuff is someone using 3D printers to print the cores for a mold. All right, so this core is printed in bioplastic, PLA, cased in plaster, and then baked till it's red hot, and all the plastic just evaporates and everything, and then they pour metal into the resulting hole. That particular one is the Venturi jet for a jet boat. We've got various jigs being made to hold things in places. So we're familiar with 3D printers being used to enhance tools locally, and that allows people to create a lot more, to create valuable products and compete with, say, farming things out to China and stuff. So what can you do when you start hacking your printer to do something else? Your hack doesn't need to be sophisticated to actually pull a good stunt off. Okay, so we've got a pen there. I've reinvented the plotter. Great. But that pen can be loaded with etch resist. It can be loaded with conductive paint. Load it with fire trail ink if you want. But you know, just doing a simple hack like that can achieve a good result. And well, you know, it's a hack. Hacks don't all have to be actually practical, do they? All right, this is not recommended by the New Zealand Heart Foundation. Just click home to celebrate the new year. All right. So let's sort of hack something. Here's the victim we're going to hack. This is a modified Wade extruder, standard way of printing plastic on a lot of 3D printers, fitted with one of the hot ends that we make. Takes 3mm filament in through a hole in the top, squirts molten plastic out of the bottom. Arduino controlled stepper motors provide the muscle to do the job. The plastic filament is pulled through the system by you see that rough patch in the middle of the screen on the bolt. All right, that bearing, big shiny bearing at front, that's pushed up against the rough patch on the bolt. Plastic goes through the rough patch, it's pinched there, you turn the big gear around with the stepper motor and the plastic gets pushed out the bottom into the hot bit. Okay, it's a lot like the pinch wheel in a MIG welder, if you're familiar with MIG welders. So we can hack that. We'll use a smooth bolt instead of one with a rough patch. We'll drill a bigger hole down the middle of the thing, literally with a drill. And we put a piece of silicone tube down the middle. Now, if you picture a tube of toothpaste going into a mangle, all right, okay, now take the end off the toothpaste tube and try it again. As you turn the handle on your mangle, toothpaste tube goes in, toothpaste gets squirted out at the end. All right, same principle here. As that silicone tube gets pulled between the smooth axle and the pinch wheel, it squishes the liquid out of the tube. It comes out of the micro pipette, out of the pipette tip. That's actually a crimp ferrule that we just pushed into the end of it. Now, there's 400 steps per rev on that stepper motor. It's 3-to-1 reduction gear. So you can actually dispense very small amounts of liquid very precisely with that. So it's a biohacking tool. And you can also run the thing in reverse. So it can suck liquid back up from a reservoir and then deposit it again somewhere else. So yeah, what we've actually invented, of course, is a very, very simple peristaltic pump. Now, if you want to start pushing large amounts of liquids around your 3D printer, you want to use that sort of design. Of course, we're talking 3D printing, so you can 3D print one. Excellent. The problem is that kind of design requires a lot of torque, right? So you can get stepper motors with gearboxes on them to increase the torque. They tend to cost a bit, but again, it's 3D printing. So we can get really creative. We can actually put the peristaltic pump inside the gearbox, all right? That can actually only be assembled by 3D printing because you can't slide the gears through past one another. It's the only way you can actually make one of those. All right. 3D printers themselves tend to be made up from open source hardware. That thing's all Arduinos and ramps boards and everything, all totally open source. And because of the popularity of 3D printers and hobbyists, these sort of 3D printer parts are available from multiple vendors at reasonable price. So, I mean, you've got LCD controllers, you've got stepper motor controllers, you've got temperature sensors, you've got high current drivers, and all sorts of stuff. And it really just cries out to be hacked, doesn't it? So, I mean, you can go to real extremes. I mean, this guy has built an air hockey table from just using the stepper motors and controllers and everything to drive the air hockey table, and one of those was it the PS2 camera things to spot where everything's going, and that quite successfully humiliates puny humans at their favourite pastime. And you can do some nice hardware hacks. This is using a a CD and DVD drive mechanism to provide the movement of the axes, and hiding behind everything there's a little motorized syringe affair. Now, you familiar with Jello shots? Yeah? You make little jellies in glasses, usually using a high percentage of vodka or something like that. They're sort of found at maker parties. So what this is doing is it's using a hypodermic needle as a print head, and it's moving that needle around inside the Jello shot, and while it's doing that, it's putting food dye into the Jello. So, all right? So you can print things inside the Jello shot. All right? Yeah. Now, you know, I haven't got a thing about jelly. There are just so many cool things you can do with the jelly. This is some serious jelly. All right? Now, this is an extruder which is loaded with sugar glass. All right? It's great fun. It's on Wikipedia. You can download it and make it. And it's the stuff they make stunt glass out of, so when people hit one another over the head on the movies with glass bottles, it doesn't leave much real blood. So a chap called Jordan Miller from the Tissue Microfabrication Laboratory at Uni of Pennsylvania. He's a founding member of Hive 76, and he's also a RepRap core developer. Now, what he's done is quite clever. He's used a sugar glass extruder to make these little objects. Now, those little objects are then subsequently put inside agar jelly. You know, the nutrient stuff they use in biolabs, right? Now, that's sugar. And when you put sugar inside jelly, which is mostly water-based, the sugar dissolves in the water in the jelly and disappears. So you're then left with a whole load of little cavities inside nutrient agar, which this guy then turns into blood vessel networks in 3D. Now that allows you to do a whole load of biological emulation, which much more closely resembles the way that things work in our bodies than does, say, stuff growing in a little 2D Petri dish. All right. So he's using something called a Barracuda extruder, which is the thing wrapped in yellow tape up there. It's pneumatically based, and the yellow tape is something called Kapton, which is heat-resistant tape, and that's what everybody sort of, it's your high-temperature duct tape for wrapping stuff up with when you're bodging it, right? So it's pneumatically operated, it's filled up with sugar glass. Pressure causes sugar glass to go out. When there's no pressure, sugar glass is fairly thick stuff, so it doesn't dribble much. So we had a crack at making one of these things. Here's the guts of our system. It's got a little relay there, so it can flip between driving these two solenoid valves. All right? So we have compressed air coming in one tube. First valve lets it in, and it comes out the pipe and goes into the syringe and pushes whatever is in the syringe out all over the desk, or, well, when we fit it in the printer, it goes over the print bed. And the other valve is closed. All right? So that's how you extrude. Clever part is you want to stop extruding at some point. Okay? If you just turn the air supply valve off, the pressure inside the syringe will cause everything still to fall out for some time. So you close off the air supply and then you open the other valve, and that vents the pressure out, so you can turn the thing on and off fairly quickly. All right? So that's how that Barracuda extruder works. You can also do it the obvious old school way, which is to have some kind of pusher drive mechanism operated by a stepper motor and use a syringe. It's, you know, no-brainer, but it's a bit bulky and it's not really hacky enough for me. Okay. So you can have some remixes. We all know remixes. Yeah, where you take a couple of ideas, slam them together, and something weird and wonderful comes out. All right. So, what do you think happens if you cross coffee with a 3D printer? You get a deliciousness, yes. A hyper 3D printer. Or you end up...
Go back.
Oh, sorry, back. Okay, I'm going back.
Thank you.
We cool? Excellent. All right. I haven't been drinking coffee. No, not me. It wasn't coffee. It was water. So, you end up with the Textpresso. All right. Now, this was made by ZipWhip actually to promote their SMS gateway system, but it's quite cool and it uses a lot of 3D printer hacking. So, you have an espresso machine and a mechanism over the espresso output, which is what they call an ink shield. Now, this was developed when we were mucking around with 3D printers. It uses an Arduino to drive an inkjet cartridge. All right. Now, it's a bit hard to get unchipped cartridges these days, but they do still exist. And yeah, you have one of these things filled with some food-safe colorant, and you have a couple of servos to move your beverage around underneath the espresso machine, and then you can print the name of the person who asked for the espresso on the top. All right, so that's great. Now, this does have other applications. The original inkjet shield was actually done so that you could print biomaterials. Now, you have to be careful to get the right cartridge here if you're going to play this game at home, because there are two kinds of cartridge in inkjet world. One of them uses a piezoelectric element to push the ink out of the little holes. That's great. That's the one you want. Okay. The other one sort of passes an electric charge into the ink and vaporizes it as steam, and that steam pressure pushes the now cooked biomaterials out of the nozzle. You don't want to use that one. All right. Let's do another remix. Okay, a tattoo gun and a 3D printer. I think we can see what's going to happen here. No, yes, a dermal printer. Dermal print. It's a thermal printer. Oh, never mind. So this is by appropriate audiences. Yes, it is real. It it can't actually sort of measure the contours of your arm while it's doing it. So you sort of model the arm and then tell the thing to go over the top of it, and it has a stab at doing it right. A stab at I got one of those, and I'm not putting my arm in that thing. Okay. Oh, what else can we have? Oh, a griddle and a 3D printer. This is sounding promising. Yep. So, bacon would be good, wouldn't it? No, but this one is almost as good as pancakes. All right. So we're having custom pancakes. This is the pancake bot. These things are called electric frying pans down in this part of the world, but principle's the same. Another one of those pressurized extruders. Wonderful. And if you're really feeling hacky, you can build the whole thing out of Lego. And then you can also build a Lego maple syrup dispenser to go by the side of it, which this guy has also done. Making me feel hungry. Okay, more food. All right, so we combine cold custard and a 3D printer. Any ideas for this one? No? Okay. Ice cream printer. Yeah. There's a thing called an anti-griddle, which is basically a big freezer plate. And you can sort of compile food on this freezer plate and serve tasty cold treats. And of course, cold custard is ice cream. So, yep, you can do that one. Oh, this one's going to make people wince a bit. Okay, another remix coming up. a vibrator and a 3D printer. Now what could this be? No, we are not entering the realms of teledildonics. This is actually a powder printer. So you put your powder in the little funnel thing. You have 3 little vibrating motors from, like the phone that buzzes in your pocket, and right, yep. And when all the little motors buzz, it causes the powder to fall out the little hole in the bottom of the funnel, and you can draw around with it. It's kind of cool. Okay, so we've got a vibrator making lines of white powder. It's a bit sus, but the powder doesn't have to be foodstuffs. It's sugar there, but I mean it could be enamel, catalysts, whatever. They started off with 1 motor and discovered they needed 3 to make it work. Okay, this one was developed for New Zealand, so wool and a 3D printer. All right. Yeah, absolutely. What do you think we're going to get here? We're going to get 3D loom. All right. So this one actually puts a bit of sort of like hot glue on the outside of it, so that you can actually make it stay in a 3D shape as you weave it around the forms. All right. A toupee? I don't need a toupee. I have plenty of spare. Yeah. Okay. All right. So there's some people who may wish to do that as a dev project. So we start wondering when we push the right button. Next slide, please. Hello. And we start wondering why my machine's locked up. Come on. X is still there. Yes, okay. So, where to from here? All right, 3D printer in every home? Nah, don't think so. Why? Well, in theory, everybody can sort of beat things out of metal if they want to. All right, it's not hard to do forging. Humans have been doing it for thousands of years. Even I can manage simple blacksmithing. Do I do it very often? Not as often as I'd like. Everybody in theory can get a sewing machine, sew their own clothes. They don't. All right. They don't actually understand what they want to achieve, how they want to achieve something. They don't understand the processes necessary to do it. So they tend to basically get people who know what they're doing to actually do the job, because designing 3D stuff is actually quite hard. So I can see that you'll have sort of like the local hacksmith who will do all the 3D manufacturing stuff for you, just like a copy shop, just like they used to have the old blacksmith in their smithy in days gone by. So where will 3D printers go? Well, a 3D printer, when you think about it, it's just a 3D robot with a fancy end effector. You can reverse the process. You can have a robot arm, and that'll make a perfectly acceptable 3D printer. People have sort of reprogrammed welding robots to sort of print pint mugs out of steel and things like that. So the concept of what a 3D printer is, I think, will change from these rather primitive little 3-axis boxes. We're starting to see the Delta bots using the sort of 3 triangularly placed rods to move things in 3 dimensions with cunning maths. What we're starting to see is people also working on complicated feedstocks. There was a recent news article in the Science Press about people who are now starting to coat little tiny spheres with DNA. And there's like 2 DNA strands, they're complementary, they stick together. Yeah. Well, if you coat the different spheres with different brands of DNA, as it were, you can cause them to assemble in certain ways to make three-dimensional structures. So as the material that you're printing gets smarter, your 3D printer basically becomes a sort of more of a positioning system for smart materials. So, I mean, ultimately you'll get this feedstock to be smart enough to crawl into place on its own. But I think that's one of the directions we're going to go in. But for the meanwhile, what we've got is the process of having anything that can move in 3 dimensions potentially being a 3D printer. This is real. This is a quadcopter armed with a foam gun that shoots quick-setting foam. The idea is that this thing approaches a section of Chernobyl that still glows in the dark, builds a little wall around the bit that still glows in the dark and fills in the space, and then another quadcopter comes along, picks it up, takes it away for disposal. So we've seen people doing hex bots that have got little deposition nozzles on them, and they walk around and they build structures in different places and move between places to construct things. It's possible for this sort of robot to build a structure and then climb on top of it and then continue building. So this can go in a whole load of different directions, and basically it's being handed over to you guys. So go for it. All right.
Vic, I saw some stuff in the news about 3D printers being used to print prosthetics and casts and things like that. Are they actually making things better, or are the rough casts that they do in orthopedics still better than the printed ones?
Yeah, printing prosthetics and casts, it's a great application. The casts are handy because they sort of allow a lot of ventilation of say your arm. You know, it doesn't get sweaty and sticky under it. You can actually put your finger under there and scratch that itch, which I've done that before. It's the prosthetics, it's really useful. You see a lot of them done for small children. All right. Now, small children, I don't know how many of you have got small children. I had them long ago. Now they're helping run LinuxConf. Small children tend to lose the occasional shoe, and they tend to break things. All right. Now, if they lose a prosthetic limb, this is really expensive. All right, and kids are very good at losing things. A prosthetic limb can cost thousands of dollars. All right. The other thing kids do with shoes is they grow out of them, and they grow out of them really quickly. So you can't afford to spend thousands of dollars every time a kid needs a new prosthetic limb. Yeah. So being able to 3D print a prosthetic limb at relatively low cost is great. Plus, when the kid breaks their finger, they can just print a new one. All right.
If only you could do the same.
If only I could do the same. Yeah. So the prosthetics are real, and we actually, it's got to the point where we actually stock the printing filament in a variety of skin tones. All right, and we thought, okay, that's just used for the grown-ups. The young ones, they actually want a red, yellow, and purple prosthetic hand. They think that's really cool. All right. We've got one kid running around with some prosthetic fingers that are printed in glow in the dark. Go figure. But yeah, it's a really good application of this kind of technology, and they seem to work better than the expensive limbs in some cases. So, yeah. Aha, we have another question.
Hi.
Yep.
I don't know if anyone else has any other questions, but if they don't, do you maybe want to talk about some of the unique design decisions you've made in designing your printer?
Yeah, how are we doing for questions? Yeah, okay, go for it. All right. So this is the official version. New Zealand has a lot of wood and a lot of aluminium because we got a lot of hydro, and so they use that for making aluminium. So wood and aluminium feature strongly in this thing. We wanted to make as much as we could locally because importing stuff to New Zealand, a bit of a hassle. So the more we can make here, the better. So we got a CNC machine actually made in New Zealand as well, which is great, supporting the local economy. And we machine the frame and these little bits here, which could be printed, but we actually find that printing these pieces takes a while. So if you're trying to make quite a few of these things a week, you want to machine as much as you can with a CNC machine because it just happens quicker. We still put all the plans up there, so if you want to print your own part, you can print a replacement. Right? So we've made the bearings from acetal rather than importing bearings, so we can change the design. And we've also the bearings are also those are the white bits there. They're actually part of the structural part of the carriage. So we've simplified the design so there are as few parts as possible. There are only 4 bolts holding the frame together. So they're about year long, but there are 4 of them. They hold the whole thing in compression. It's really easy to take apart, put back together, and we've carried that philosophy through. So if you actually look for screws and little things holding stuff together, you won't actually find very many. These boxes, they're held together with 2 bolts each, right? The aluminium tube here, it's just held in place with a wood screw going through the top of it. So we've really tried to keep it as simple as possible, and of course all open source. Yeah.
Hi. Okay, I've got a question as well for you, Vic. I understand it is possible to stop the extrusion halfway through and change colours. Is there any possibility of making multiple extruder, multiple hot end printers so that you don't have to keep changing if you want to change colours?
Yeah, multiple hot end extruders been around actually for a while. Every so often somebody will come up with a new version. I think the current record is 5 independent colours into the same extruder. There are a few problems with sort of having more than one nozzle on the machine. Primarily, while one of them's printing, what's the other one doing? Right? And the usual answer is it's dribbling plastic over whatever you've just printed. All right. If you want to put them into sort of 2 filaments into the same nozzle, you have to make sure that heat doesn't propagate back up the filament and make it too soggy, the filament that isn't going into the system, and make it too soggy to actually push through the system. Because once you make it soggy, it sort of becomes very rubbery, friction increases, it's actually hard to push through the guides and things like that. Warm, soggy, yeah, same thing. When you got multiple filaments coming in, the people think, all right, you'll have a red one and a green one and a blue one, and then you can mix them to make all colors, right? No, actually things don't tend to mix very well. It's a very viscous material in there. There's no turbulence to stir the colors up, so you push red, green, and blue in. It's a very interesting effect. You get red over that side of the object, green over this side of the object, blue over that side of the object. And I'm doing mixing colors of light, not pigments, aren't I? So yeah, red, yellow, and blue. Yeah, cyan, magenta, and all it's yeah. And then you also discover that there are things like white. You can't mix colors to make white. So I need 4 input things. And then you discover that actually when you try and make black, it sort of comes out turd brown. So you actually want to put a black in there as well, right? And then you realize that there are transparent filaments as well. So you end up with a sort of octopus thing in the middle, and it starts getting large and unwieldy. So really what you want to do is you remember that inkjet head thing? If you printed a layer of plastic, then you could go over it, print the color on it, and stick the next layer on top. So there are other ways of achieving that effect. Yeah, over there.
Hi. I dimly recall a few years ago there was a lot of work or a contest about sort of creating filament on the fly, making it from scrap plastic, something like that. What's the status quo on that sort of investigation?
Making your own filament can be done, certainly. We have a filament production line. It's about 10 meters long. Right? Trying to do it on a desk, you're going to have to make a few compromises. Basically, it's going to go a lot slower. You have to cool the filament down after it's come out the extrusion machine. So if you run these things too fast, you just end up with a floppy noodle that does its own thing. Most people think, I have one of these machines, I can recycle my old printed objects. Okay, you don't want to do that. For starters, you've just maltreated the plastic by heating it up quite a lot and squirting it out. There is a limit to the number of times you can heat plastic up and squirt it out and reuse it. Secondly, when you've printed it out into the real world, it tends to acquire things like the paper tape you printed it out on, fluff, cat hair, that kind of thing. And when you put that into your hopper to make plastic filament come out again, you end up with plastic filament that has bits in it. And guaranteed, any bit in that filament is going to find that little hole in the end of your nozzle and clog it. All right? So you think, okay, I will get virgin plastic granules and I will put them into my filament machine. That's great. Have you ever tried buying just a few kilos of plastic granules? Right? It sort of comes in 800 kilo containers, right, which you probably wouldn't even get through the front door. And if you speak very nicely to the supplier, and they're used to supplying you, they may sell it to you in 25 kilo pre-packed bags, which are sealed in nitrogen to stop the granules absorbing water vapor. While it can be done, it is a lot of palaver. Now, that said, if you're in a part of the world where you haven't got anything else, go for it. All right? Yeah.
So how far can you scale that up? Can I buy one that's big enough so I can't get it through my door?
Yeah, that's actually one of the limitations for the next size up this machine. We make one that's 400. These are 240 by 250 by 195. We do one that's 400 by 400 by 250. All right. Local industries use it for sort of printing those jet boat nozzles and things. The main factor on that one is the width of a standard doorway. Right? It's as big as we can make them and still get it through the door. It's also as big as we can make them and still get them into the back of my four-wheel drive, which is another issue. So yeah, they can be made big. There's a bit of work going on with suspended print heads. So you sort of have 3 guy wires coming in to a suspended print head, and by shortening and lengthening the wires, you can make the head move around quite a large area. So yeah, you can scale things up in various interesting ways. Sorry? Print in buildings. Yeah, I think the Chinese have got one that does a 10-meter cube. They also have a 10 by 3 by 3 which does laser sintered titanium, and they use that to print the structure of their latest generation of jet fighters. So, any more? Or are we done? We're done.
Thank you to our resident mad scientist.